we will talk about state transition systems. And state transition systems are used to describe formal models of distributed algorithms. That is the reason that we want to talk about state transition systems. So a state transition system consists of the following: a set of states, a rule for which state to go from each state. This is a binary relation that tells you from which state you are allowed to move to the next state. And sometimes it is a transition function, not a transition relation, when in a given state you can only move to one state. And we have our set of initial states or starting states. So let us look to an example of a sequential algorithm. So this is not a distributed algorithm. Normally you describe sequential systems as functions from input to output, but they also could be described by using transition systems, state transition systems. So here is an example. This is a very simple example. You initialize a variable x, and then you go into a loop, and then you update the variable x. And in fact, this program corresponds to the following state transition system described as a graph. So let us see this now. So we have a set of states, x1 to x1 prime. And initially, this algorithm is in this state. This is the state where x, the variable x, has the value 0. So this is the state where it is. So it is in a state x0. Then you execute the while loop, and you come to this program point. These are called actually program points also. And in this program point, in fact, the state of the system is at x1. So at x0, our variable x has the value 0. And at x1, our variable x has the value 1. And the whole state of the system is described by the program point where you are located and the state of the variable x. Then you do the test again and you move back to the same program point. But the process is in a different state. It is here. So it has the same program point, but it has x equal 2. Then the while loop test is false, and then you move to the final state after executing the assignment x equal 1. So you are come to this final state, and this final state has this program point and x equal 1. So you can see here, these are our states. Then we have a transition function, because from each state you only move to a single unique state, which take you from x0 to x1, this one, and here from x1 to x2, this one, and here from x2 to x1 prime. So you are here, and you start the whole execution from the initial state x0. So we have here described a state transition function for a sequential algorithm. And the state transition function describes the process of execution of that algorithm. So sequential algorithms, sometimes we call them centralized algorithms, are modeled as functions from input to output. But distributed systems and algorithms are systems that run forever and interact with each environment. And the best way to make an abstract model of this is to model the system as a transition system. So now we are going to describe formally what is a transition system. So a transition system is a triple. It's a tuple with 3 elements. Looks like this. We have the set of all states, and then we have a binary relation on S, the states, and we have a subset of the set of all states, which are called the initial states. Then we have a transition relation, which again is a subset of the Cartesian product of S with itself. And an element in the transition relation is element of this binary transition relation, S1, and sometimes it is written this way. So given that, we can now define what is an execution of a transition system. An execution of a transition system is a maximal sequence, so it's a sequence where you start from an initial state, S0, and you move to the next state and so on, where Si to Si plus 1 is part of the transition relation. So you are allowed to move from S0 to S1 if S0, S1 is part of the transition relation, and so on. You are allowed to move from S1 to S2 if this is part of the transition relation. And in this case, we say it's a maximal sequence because as long as we can move from one state to a next according to the transition relation, then we continue our possible execution. So what is a terminal state then? A terminal state, SF, is a state for which there is no state X such that SF to X is part of the transition relation. So it means we come to a state where we cannot make any more transition and we are stuck in that state, and that is the final state. In transition system, you might have infinite executions. It means that the sequence of states S1, S2, and so on could be infinite. The sequence could be infinite. Or if it ends, then it ends in a terminal state. One more definition, which says a state is reachable. So the state Y is reachable from state X if there is a sequence where X is a star state, and this sequence of transition lead us to a state Sk where Sk is Y. And of course, for this transition has to be part of the transition relation for all I between 0 and K. We say in general a state Y is reachable if it is reachable from an initial state. So that is the definition of reachability of a state. It is reachable from the initial state. What we are going to use in this course is what we call labeled transition system. So a labeled transition system actually consists of a set of states and a set of actions, a transition relation, and a set of initial states. So here S is a set of states, A is a set of actions. The transition relation is now a tertiary relation. It's a relation that the elements is a triple, which takes a state, an action, and moves to the next state. Sometimes we write it like this. We are in state S1, you do an action, and you move to state S2, let's say like this. And we have I, the set of initial states. So the transition relation, as we said, is a subset of this Cartesian product of S times actions times S, and S is a set of states. And we can write it like this, or like this, or like this. So an execution in a labeled transition system is a sequence, it's a maximal sequence, where you alternate between states and action. So you start with an initial state, you perform an action, A1, you move to a next state, and then you perform an action and you move to the next state, and so on, where S0 is part of a set of initial states, and this triple is part of the binary transition relation. And again, we can define terminal state. It's a state SF, where there is no action and there is no state that you can move to. And we said what is a maximal sequence. You start from initial state and you continue by alternating action states. And this is maximal if it is infinite or ends in a terminal state. And as usual, reachability from some state to the next state. If you can start from that state, and by a number of transition, you move to the state Y. So Y is reachable from X. And we say a state in general is reachable if it is reachable from any initial state.